welcome to another episode of Read All About It. I'm your host, Reed. Today we're starting a new segment. I'm going to title it Read Rambles. These are going to be more lecture-based, like podcast type discussions. Today we're going to talk about statistics, and specifically statistics related to shooting and reloading. We're all aware that statistics plays a part in long-range shooting so that we can have calculated, predictable outcomes to, an engagement from, 300 yards to the ultimate extreme, multiple mile type shots. The only way that's possible is if we have predictable data from previous samples. So, by shooting previously, we're able to create equations and profiles for certain loads, certain rifles, all those types of things, so that we can accurately engage at distance. And while we all understand that those numbers play a part, most of us just plug numbers into a calculator, whether that be on our phone or Kestrel or binoculars or whatever it is, and just trust the data that comes out without understanding what those inputs are and how we can build better ballistic profiles by increasing sample size and things like that. So this is going to be at least a two-part series. Today we're going to focus on the general education and understanding of the terms and what makes up those terms, such as average and mean and mode and things like that, standard deviation, what a bell curve is, those types of things. I'm going to cover all that today. And then in a separate video, we're going to dive into some sample sets so that we can manipulate the numbers, so that we can understand what sample size does to a data set, and how, when we're shooting 3 or 5 shots over a chronograph during load development, it may or may not be indicative of what that rifle, that load, all those types of things are capable of, and that we may be just, in a lot of instances, chasing our tail. But without any further ado, I've got some notes here laid out with definitions and things like that. So we're going to have a general discussion, education on basic statistics. So, what is statistics? So statistics is the science of collecting, analyzing, interpreting, presenting, and organizing data. What this does for us is it helps us make informed and predictable decisions based on past data. In our case, that's, like I mentioned, shooting at distance, whether it's archery, whether it's rifles, anything like that, to throwing a ball. As humans, we're actually pretty good at internally calculating ballistics. But that's in relatively short range. When it comes to engaging something 1,000 yards away, that's where we need math and formulas. So measures of central tendency are all going to be, like your average, your mean, mode, median, those types of numbers. Those fall into the category of measures of central tendency. And those describe the center or typical value within a data set. So first and foremost, one of the numbers that we're most concerned about is our average velocity. So average velocity in statistics, average is just denoted as mean. Those terms are typically used interchangeably. But the mean is calculated by adding up, so the sum of all the data within your set, and then dividing that by the total amount of data that there is. So if we have 5 values for our data set, if we have 5 velocity numbers, we're going to input those, add up the aggregate, and then divide that by the number of samples in the data set. So in this case, 5. And that'll give you a number, which is the average velocity, in our case, that you are achieving with that load and those types of things. The median is the middle value, so the direct middle point between your extreme spread, essentially. So that is, in our cases, pretty irrelevant for what we do, but I think with a general overview of statistics, we should include it. And then mode, your mode is the most frequent value that appears within your data set. And you can have multiple modes. So if you have 2 numbers that are 12 and 2 numbers that are 18, they're both going to be your mode, so long as every other value within the data set only has one representation of that. So yeah, you can have unimodal, bimodal, multimodal sample sets. Again, relatively unimportant to the entire discussion of ballistic statistics, but I think it is important to understand what a mode is, especially if you're getting a lot of that repetition. And then, so those are going to be your measures of central tendency. And then, so those are all pretty basic numbers that we're all aware of. The most important of them being our average or our mean. That's the number that we put in for our velocity within our ballistic calculator. That's the number if you're building a custom sight tape that you're going to have to input in the programming to get an accurate archery tape. So then we have our measures of dispersion. So why we're concerned about that is we know not every single engagement, not every single cartridge that we load into our rifle, not every single day, the wind and the weather and all those types of things are going to be the same. We know we're going to encounter variables. So we need a way to have some confidence and measuring that confidence of a given load so that we can know our probability of accurately engaging with that shot. So measures of dispersion describe how data values are spread out. So we have our range, that's what it's defined as in statistics. We call it a range. When we're talking about shooting and measuring with a chronograph, our range is denoted as our ES, or extreme spread. And that is just, so your max and your min. So your extreme spread is the difference in those. So if we have an extreme spread of 150, let's say, that means between our lowest data set, our lowest value, and our highest value, we have a difference of 150 feet per second. The range is just the max minus the min, which is the exact same as our extreme spread though. Standard deviation, this one's a little bit more nuanced and complicated because there's a lot of different factors because of the influencing factors within the equation There's multiple variables. It's squared and square roots and things like that. So different things have different impacts. Something might swing it wildly, while another data point may make little to no change to that number. And I think standard deviation is one of the ones that we should focus on more that we don't. And so what standard deviation is, it's a measure of how spread out our numbers are from the mean, so from the average. The formula is our standard deviation equals the square root, and then underneath that square root you have the sum of your data set minus the mean squared, and that all divided by the number of values within your data set. So, I mean, that doesn't necessarily mean a ton to you, but we all look at our chronograph and we see this SD number and we post it thinking it's good, things like that. But I think a lot of that depends on the size of our sample that we're measuring. So a low SD is what we're shooting for. And what that indicates is that our data points are clustered about the mean. And so we know that through multiple engagements, our loads are going to create a standard or normal distribution, and that is denoted by a bell curve. So as the name denotes, that's a graph where we make essentially a bell shape. And what do we know about a normal distribution? We know that from the average, so from the middle of that bell curve, plus or minus one standard deviation above or below that mean, we're going to encompass 68% of all the data within that set. So as we continue to engage, whether we're actually recording the data or not, we can have 68% confidence that, if we shot 100 shots, 68 of them would be plotted within that center section, plus or minus one standard deviation from that average. So having a low standard deviation means our bell curve is a lot steeper, and we're going to have more data more closely gathered to that average, and that allows us to have more accuracy downrange. And then plus or minus two standard deviations, you're going to encompass 95% of all data within the sample. And then plus or minus three standard deviations, that encompasses 99.7% of all data that you'll ever create with that same load and everything like that. So while our extreme spread can be relatively high, if you give it enough data, our standard deviation might be very, very low. So when we're shooting and you get, like say you're shooting a 5-shot group and you get 4 that are pretty good over the chronograph that print really close to the middle or really close to one another, I should say, because we're more concerned about precision rather than accuracy. Accuracy can come from just a simple scope adjustment so that you move the group over what you're actually aiming at. But so that standard deviation, I think, is one of the most important factors, because if we have a relatively large standard deviation, if you have enough data, or I mean a relatively large extreme spread, if you have a large enough data set, you can still have small SDs, because there's still probability that that one outlier that you had that shot 150, 200 feet faster, slower, or whatever, than the overwhelming majority of your other shots, provided that those are all relatively clustered about the mean as well, you're going to still have a low standard deviation, because statistics tells us that there's still data points that will fall outside of 1 standard deviation and 2 standard deviations and 3 standard deviations and even 4. There's still statistical probability that those outliers are going to manifest themselves. And it becomes less and less likely the further we get away from the mean, provided we have a relatively low standard deviation. So that standard deviation, I think, is a more important number that we get an accurate representation of. It doesn't do us any good to have a single digit SD of 7.2, but we only have 3 data points within that sample set. Within that sample set, yeah, that's an accurate number. But as a population of all shots that you're going to take with that load, it's negligible at best. So that is why when we're doing the load development, when we're thinking about shooting long range and things like that, we need to put in the time to get as much data as we can reasonably collect. I see in the chats and the Facebook groups and YouTube and everything else, everybody, somebody watched the Hornady, Your Groups Are Too Small podcast. And I think they did a great thing by bringing these topics to light and getting them in front of more people's eyes. I think, they didn't extrapolate a ton on the mathematics side. They just said, these are the things that you should focus on without the why behind it. And so that's why I'm kind of making this podcast, is to give you the why behind it so that people can understand why it's important that we shoot 10, 20, 50 round groups and get 50 data points over the chronograph and things like that, if possible, because it just makes our solutions that much better. It makes our zero that much better. So you're not chasing, you're not making that 2/10, I'm 2/10 high today, I'm 2/10 low tomorrow, I'm, those types of things, left, right, those misses that you're getting, you can greatly alleviate those if you get a high round count group and data set, so that you have as good a data as you can to shoot a match or go hunting with, and I think especially for hunting, we see so many guys, well, I don't need that, I'm only going to shoot 1 shot in the field. That's great. That's why that matters all the more, because when I'm at a match, more times than not, I'm getting at least 2 engagements on a target so that I can make a makeup shot. And I'm only shooting at steel. I think it's even more important in a hunting situation that you do your homework ahead of time so that you have the confidence and the statistics are on your side that you're not going to have an outlier. You're not going to have what we a lot of times denote as a flyer, when it's not a flyer. It's just part of the population of data. So I think understanding these statistics and chasing the right numbers is more meaningful, and doing it in the proper manner. So that standard deviation number is extremely important, and if we collect our data properly, you're going to have a better ballistic profile. And you can rely on that more heavily. You're not going to question yourself why you missed. You're not going to question your gear. You're going to know that if you missed, it was likely user-induced more than it was random chance. And we don't want to leave those things up to random chance. You want to hit what you're aiming at. We're responsible every time we pull the trigger with where that bullet lands, and you want it to hit where you want it to hit. So the standard deviation is, I think, one of the most key features when we're talking about the statistics of reloading and shooting and precision and accuracy, because not only for our load development, yes, we want our velocity range to be precise and clustered about that mean, but we also want our dispersion on target to be low. And when we're shooting at 100 yards, our dispersion, elevation dispersion from velocity is relatively negligible, as well as dispersion due to wind, which is why we shoot at 100 yards. So, because most of those factors are still relatively negligible within that, and it gives us a relatively decent idea as to what the precision of that load is. And I probably should pause and talk about precision versus accuracy. When we're talking scientifically, precision is when all your data is clustered tightly about a single point. Accuracy is that you hit what you were aiming at. Like I mentioned before, it's more important to us that we accomplish the precision first, because we can adjust for accuracy. We have tools like rifle scope, a bow sight, those types of things, where we can adjust that to center that group over our intended point of aim and point of impact. So the statistics there are, what is the probability that we're going to squeeze the trigger, and just due to the natural statistics of our load and of the dispersion of our rifle and what it's capable of, that bullet is going to start off on a trajectory that is high and right or low and left or directly in line. So those types of things we need to account for and understand, because that's going to limit our effective range when hunting. It's going to give us reliable downrange adjustments that we can make. If we're taking a shot at 1,000 yards and our rifle only groups 2 inches over a large sample set, we know that if something goes just off the plate, low right or low left or high or left or right or whatever it is, we can adjust for that, and then our next shot goes off the plate in the opposite direction. And that can just be the normal dispersion of our rifle and of our load, which is why we're so concerned about these numbers, and we're so concerned about how it prints on paper and all those types of things, because that's the only way that we can confidently engage a shot at distance. But also, if we can spot that miss or that impact, we can correct and reliably predict that our next shot is going to be more centered up, more accurate, okay, because we had the precision element. If we don't have enough precision within our system, we can't then also make a correction to make it accurate, because there's too much unpredictability for what we're trying to do. So these terms and everything also apply to our downrange results, because you can have a standard deviation on how far those shots fall from the middle, and there's target analyzing tools like within the Hornady app, like Ballistics, I believe, is the other app, where you'll see, you can plot your group, take a picture of it, give it a known distance. If you're using a sight in target or something like that, those grids are broken up into an inch. You give it that measurement, and it'll calculate what your group size is, and then you can tell it where you were aiming. Excuse me. And it'll give you the X and Y coordinates as to how far away from that point of aim you were. And you can plot that into software as well, and it can give you probabilities. So, like I mentioned before, statistically relevant and or significant data, 3 and 5 shot groups don't give us that. 10 shot groups start to give us some trends, maybe not the most reliable. 20, 25, 50 shot groups, then we're really starting to get into reliable stuff that we can depend on. And so spending the money, spending the time at the range to get the data set that you need to build out that ballistic profile so that you can ethically and confidently engage targets at distance is actually really important. And so statistically relevant or significant data is defined as data or results that are likely to have occurred not by random chance alone. So they're predictable. And it's measured by p-value, and to have something as statistically significant, p would be equal to or greater than 0.05. That's the most common threshold that I found. And in order to achieve that, we need more data so that we can use that as a reliable source when we're making those calculations. So those are the terms and why they're important to us as reloaders, us as shooters, whether you're actually reloading your own ammunition or not. If we're shooting at distance, we're all building out ballistic profiles. Almost no one is going out and creating dope charts anymore, given the technology that we have, between the apps, between the calculators and the quality of our chronographs and things like that. We have a lot of great tools at our disposal that make shooting at distance a lot more doable, a lot more attainable for your average guy. And so taking the time up front to collect the appropriate data, like I said, whether you're buying factory ammo, reloading on your own, it's all relevant. As a reloader, we're able to change more variables to try to achieve higher levels of precision. But factory ammunition is better than it's ever been, and we're able to create very reliable models based on factory ammunition as well. And that might just be as simple as, I need to get a box of 20 of several different varieties, shoot that entire box of 20 at the same point of aim and at the same over a chronograph, and that will give us a pretty good idea of what we can expect if we go out and buy some more of that same lot ammo. So I guess, if you guys found this helpful, like I said, this is just kind of the introduction. Next episode, we're going to dive into the application of it. and we'll get on the computer, we'll use some Excel, we'll generate some sample sizes, and we'll start tweaking numbers to see what that does to our numbers, so that when you see data present itself, you don't end up chasing your tail and wasting components and saying, oh, I think I need to, because today I shot an 1.5-inch group, and 2 weeks ago this load shot 3/10. So that you don't throw the baby out with the bathwater, and get the cart ahead of the horse, and all the other cliche sayings, so that you can save time and money, and get the most out of your time at the range. By having this knowledge, I think it'll give you more tools at your disposal to understand the data that you're getting out when you do go to the range. And if you have the opportunity, if you have like the Garmin or the new Athlon or any, even the new Lab Radar, all of those are pretty small footprints. And whether you're going to shoot a match or you're going to the range, having that attached to your Arca rail and getting 100 data points or more of information on that load is going to give you a ton of valuable information so that you can analyze that data. Because like I mentioned, every single day is different. The weather is different, the temperature, humidity, all those types of factors, those have different impacts on what our bullets do downrange, what the internal ballistics are, burn rates of powders, all those types of things come into play with those variables. And we can only control so many variables, and that's part of why we reload, is to try to control a few more variables. But no matter what we do, there are going to be inconsistencies within our ammunition, within our rifle, all those types of things, so that it makes it challenging to predict from shot to shot exactly what's going to happen. And so, and then throw in the human element, and it's a crapshoot. But the more we practice, the more information we get, the more data we have, the more reliably and the more precise we can create a accurate shot downrange. And this applies to archery equipment too. I see a lot of guys shooting over a chronograph and only shooting 1 or 2 arrows. It's like, you're going to be out there for a range session. It's nothing to shoot, the 25 arrows you're going to do over that chronograph. Why are we only stopping with 1? Oh, I got 282 feet a second. I'm good, I know. When we're talking about rifle velocities versus archery velocities, plus or minus, a new bow shooting a hunting weight arrow is capable of anywhere from 280 to 310 feet a second. If you're 3% or 1% high or low, that's only 3 feet per second plus or minus. So that's not that big a spread. Now with rifles and stuff, we're talking 2,500 to 3,500 feet per second there. So we're talking about 250 to 350 feet per second to create a 1% variance. So you only having one data set with archery, or one data point, I should say, is also doing ourselves a disservice, because there will be variances, and like weighing all your arrows to see if one weighs slightly more or less and what that does to velocity. As we shoot, our strings are changing, just like Rifle powder burn rates and things are changing given the weather. The more we shoot, the more those strings stretch and get worn out. Just the way the energy is stored can vary slightly from shot to shot. What we do with our body, how hard we're pulling into the back wall, all those human elements and variables. So I think gathering more information there can also help us build more confidence in our systems. And so with that, I'm going to sign off for today. I think this gives us a general overview. Start here, learn about what it is that we're actually measuring. Think critically about it. I started doing larger sample sizes and changed my load development. It would have been probably about 2018 after I started shooting PRS. I started thinking critically about the load developments that I was taught, the load developments I saw online, and I'm like thinking to myself, if we have even our most precise loads, we're having an extreme spread of 50 or better, that what are the odds that when I'm shooting one shot in a ladder test, what are the odds that is the actual average of, if I loaded up 50 rounds of that and shot all 50 rounds of that charge weight, that one round was going to be indicative of the average? It's not very good. That probability is not very good, because we know from statistics that 38% of our data is going to fall outside one standard deviation. So even if our standard deviation is, let's say, 12 feet a second, plus or minus, from the average, we have a 38% chance that one shot is over 12 feet per second from what the actual average would be if we took a population size sample. And so we can't reliably count on a ladder test of 1 or 3 or 5 shot samples, and it's not feasible to do a ladder test of 50 rounds or of 10 rounds or 20 rounds. The amount of money and time and energy and barrels that we'd go through just to chase our tails is silly. So developing better load practices, we're really fortunate that we live in a time in which machining tolerances and componentry and all of that is creating a confluence of precision that we can take advantage of, because you don't have to go out and buy a custom rifle to get something that shoots in sub 1 minute over a large sample size. When we see rifle manufacturers create a accuracy guarantee of sub 1 MOA or sub 3/4 MOA or even half MOA, whatever that is, when you read the rules, it's almost always a 3-shot group, because given enough data, given enough opportunity, there's pretty high likelihood that you can get 3 shots to print within that given criteria, but it's not indicative of the actual average that you're going to print on your average day that you're going to go out. That's why us as consumers, we should be more worried about not what the guarantee is on the box, but what we see downrange, and adjusting our expectations accordingly. The odds that, especially when you add the human element in, the odds that you can take your hunting rifle and print it for 20 rounds under an inch isn't that great. Now, I'm not saying you need to go out and shoot a string of 20 shots all in a row. Shoot a 3-shot group, let the rifle cool. Shoot a 3-shot group, let the rifle cool. Those types of things, so that you're getting a accurate representation of what a 1-shot engagement or multiple shot engagement on an animal or in a course of fire is going to result in. If you're shooting your PRS rifle and you have stages that are on average 10 shots, shoot a 10-shot string so that you get a real world representation of what your rifle is capable of, and then come back, let the rifle cool down, and then shoot another 10-shot string. You're probably going to have 30 minutes in between when you're shooting one stage to the next. So nobody's advocating that, to shoot a 50-round group, I have to sit there and just hammer away and scorch my barrel out. Nobody's saying that. And the other thing is, in order, if you've sighted in your rifle and you've got a good hard zero, if you're going to go out and shoot these types of groups, what I do is I dial off of my zero, because when I'm trying to see how precise I can be, I don't want to degrade my aiming point, as well as try not to create as much anxiety for myself, because when I'm shooting at the bullseye and my bullets are landing on the bullseye, it's going to get harder and harder to have a fine, precise aiming point the more holes I punch in the paper right there. And not only that, mentally I'm staring at this tiny, tiny group, and each shot is going through those same holes. And then I'm thinking to myself, don't screw it up, Reed, don't screw it up, don't yank the trigger. And when I can't see that and I'm not focusing all my attention on all those previous shots, I find I'm more precise because I don't give myself that anxiety of, telling myself don't screw it up and seeing those results and focusing so intently on those results. I shoot more relaxed, and my groups are better. So those are a couple tips I would do. And yeah, let's have an honest discussion about the load practices we're doing. Ladder tests are valuable, but I would argue they're only valuable for finding pressure, right? Pressure is relatively uniform, and pressure fluctuations of 1%, which might yield a velocity change of 1%, and those types of things are going to manifest themselves in a similar function, and it's more of a gradual progression that we can see those pressure signs in our brass and things like that when we are analyzing that. So yeah, I would use a ladder test if you're trying to find where pressure shows up in your rifle, and then come down slightly from that, so that you have an idea for that. But most of us, if you're using book data, and as a starting point and trying to work up from there, if you have a rifle that can shoot, if you're capable as a marksman and have good fundamentals, good rest, those types of things, good conditions on that day, good lighting. I don't load up ladder tests anymore. I load up 10 rounds of a charge weight that achieves the velocity that I'm shooting for. When I'm thinking about load development, I'm choosing a bullet designed for the task. Then I am choosing a powder that I know is hopefully as temp stable as I can get, that achieves the velocity that I'm trying to achieve given my barrel length and other deciding factors. I have an idea, I have an aspiration as to what I want this load to do, because I have a specific task in mind for this rifle, for this hunt, for these types of things. I need it to do X, Y, Z, and those types of things. I have an idea of what those things are. Now, obviously, I have a tolerance window within that, because everything's different. What the book says my velocity could be in my given rifle could be slightly faster, could be slightly slower, those types of things. It's just a starting point. Same thing with accuracy. I have a tolerance threshold that I need to meet for a given group size, given the right sample size, those types of things, and adjusting your expectations accordingly, given the sample size that you're shooting. And so I load up 10 rounds and I shoot those over a chronograph at the same point of aim. And if that prints within my tolerances, I'll go and I will load up. Essentially, that's going to be my load then. And then I start spending my time building up my data set so that I have the most comprehensive data set that I can, to have the most confidence that I can when it comes to crunch time. I would much rather spend my time practicing for myself, shooting the same load, even if it isn't as precise as it could be if I spent all the time tracking down all the right components and everything like that. I will sacrifice that because the human element, my abilities, I think, greatly outweigh that tiny little potential gain I could get from that. I could shrink my groups substantially by practicing myself versus practicing my reloading skills. And so I don't spend a ton of time doing that. One, I think it's more fun to shoot than it is to load. But I think all those factors need to be weighed and put our money and our time and our effort where it's going to yield the most results. And yeah, here I was saying I was going to sign off, but as this is titled, it's Read Rambles, so I get on tangents and I ramble. Yeah, I think if you start thinking critically about what you're doing, because most of us, we were taught by old timers, we were, our dad, our uncle, whoever, the guy at the range, taught us to reload, and we just adopted their reloading practices because on the face of it, yeah, it makes some logical sense. And then you start thinking about it, and if you think critically about something, you're going to find chinks in that armor. You're going to find little things that exist that they may not have thought of, just because what they were doing was yielding the results that they were after, but maybe not as quickly as it could have, or with more effort and more time and more money spent, where you could have spent that time, money, and effort in a different area and saw larger improvements. And that's what I'm after. I can't speak for you guys, but I think most of us would rather have more time with our family and our kids, as well as doing what we actually like, which in most cases is putting those rounds down range and hunting and shooting and pursuing those things rather than sitting at the reloading bench. Now I enjoy sitting at the reloading bench and yielding the fruits of my labor when I do win a match or shoot well in a match or harvest an animal with a round that I loaded. It is meaningful, but it isn't as fun as actually putting those rounds downrange. But I think I've adequately covered the beginning of the topic of statistics in reloading. If you guys have questions, want me to break down the formulas, anything like that, hit the comments, ask me the questions. I'll answer them as best I can. I'm not a professor of statistics. It's just something that I've studied on my own in order to better understand what I'm trying to achieve. Like I said, I started thinking critically about stuff, and in order to think critically about it, I needed to understand what these numbers meant and how they're manipulated, what things are weighted, and all those types of things. So if you've made it this far, I appreciate you. Stick around. We're going to, like I said, do some Excel spreadsheet work, and we're going to take a look at data sets, and I'm going to show you the influence that 3, 5, 10 shot, 20, 25, 50, 100 shot sample sets, what that does to the different statistical numbers that we are concerned about when we start manipulating some numbers, so that we can see how these things correlate, and why some things show up the way they do. So thanks again for sticking around. Like I said, we'll catch you on the next one, and hope to see you guys there.